Tonight we're going to be looking at section 4.7, which is the last section we'll be covering in chapter 4, and it is on congruence transformations. Before we go straight into that, we need to actually define what it means to be a transformation. A transformation is just an operation that maps an original figure onto a new figure. That is a transformation. It's just a original figure that is mapped onto a new figure. And a transformation, it can change the position of the figure, it can change the size, and it can change the shape of the figure. But what we're going to be looking at specifically tonight are congruence transformations. A congruent transformation, it preserves length, it preserves distances, side lengths. So the transformations we're going to be looking at tonight won't change the size. The size and the shape of our figures will stay exactly the same. That's what it means to be a congruence transformation. The size and the shape don't change, just position changes. So it's a transformation where just position changes, nothing else. So for instance, I could take ABC, that would be my original figure. We also call that the pre-image. The pre-image, that is the original figure. And if I want to perform a transformation, I can do that transformation right there. I can just slide it up a little bit. And I can map it up here. And a congruence transformation would be one where the size doesn't change at all. You can see here that the size has changed some, but I'm just not good with guessing the size on that. The new image, the new figure here is called the image. So the pre-image is the original figure. The image is the new figure in a transformation. So there are 3 different types of transformations we're going to be looking at tonight. The first one is called a reflection. So with a reflection, that really is just a flip. So if an image flips, that means it's just a reflection was performed. And for a reflection, there has to be a line of reflection. And a lot of times that line will be the x-axis or the y-axis that it flips over. And so a reflection is just a flip or a transformation over a line. And we call that line the line of reflection. Okay, so you can see here, looking at these 2 shapes, this is an example of a reflection. You can see that ABC, that triangle, was reflected across the red line to create a new image called triangle XYZ. So this is an example of a reflection. ABC would be your pre-image, and triangle XYZ, that would be your image. And now the easiest way to tell whether or not you're looking at a reflection is that the vertices of the triangle, or whatever figure you're looking at, will all be the same distance from the line it's reflected over. So for instance, if you look at this red line, C and Z are both 1 square away from that red line. If you look at B and Y, they are also both 1 square away from that red line. And then if you look at A, it is 1, 2, 3, 4 away from that red line. And then let's look at X, it is also 1, 2, 3, 4 away from that red line. So we know that that's going to be a reflection because A and X are equidistant from the red line, B and Y are equidistant, and C and Z. So next we're going to look at a translation. A translation can also be called a slide. That's an easy way to think of it. So say you take a piece of paper on a table and you slide it over to the edge of the table. That would be a translation. You just perform that. So it's just another way to describe it is a transformation. That moves all points so all the points in a figure the same distance. So all points are moved the same distance. So you can see here that I have an example of a translation, and every point on these figures should be moved the same distance. So let's look at that and see if it works. So from J to M, let's see how far that moved. We have 1, 2, 3, 4, 5, 6. Whoops, I kind of ran off. So from J to M is that length. From K to P is that length. It's kind of hard to count because they're diagonals. And L to Q would be that length. Now, all those purple lines are the same distance. They are all the same length. That's how we know that that one is a translation. So when every point on one triangle or on one figure is moved the same distance to your new one, that means it's a translation. So they're all moved the same distance. All right, and then the last transformation we're going to look at is called a rotation. Another way to think of a rotation is just turning something. So if you put a piece of paper on a table and just turn it facing a different direction, that would be a rotation. You rotated it. All right, another way to think of this is just a transformation. Around a fixed point. And we call that fixed point, so it's called the center. Or the center of rotation. Either way, you can think of it. All right, so a rotation is just a transformation around a fixed point, some fixed point. So you can see here, I've given you an example of a rotation. So triangle RST is rotated along a fixed point to create a new triangle, triangle FGH. All right, so now what I want you to do is we're going to see if we can identify the type of congruence transformation that's shown. And remember, these are congruence transformation because the size and shape of our figures aren't changing, only their position. So let's look at the first one. So we have this green image that is being transformed to the blue one. So we want to know what kind of transformation that was. Was it a reflection, a translation, or a rotation? So was that figure, did it flip, did it slide, or did it turn? And if you look from the green to blue, that figure turned. So that is a rotation. That would be the type of congruence transformation in this one. So for instance, you can look at the origin. That's actually the center of this rotation, and each point is the same distance from that center. So we know that this has to be a rotation. So let's look at the second one. So did this one slide? Is it a translation? Did it flip? Is it a reflection? Or did it turn? Is it a rotation? So if you look at this one flipped. So this would be a reflection. a reflection. So you can see, remember with reflections, they're the same distance, the points are the same distance from the line that it flips around. So if we look at each one of those red points, they're 1.5, 1.5 away. If you can look at these points, they're each 2 away. So these are congruent, these are congruent. So we know it's a reflection. And then the last one here, part C. Does it slide, does it flip, or does it turn? And you can see that it just slides up the same distance. Every point is going the same distance here. So you know that that is a translation. All right, so what I want you to do now is to see if you can do these 3. So I'm going to pause the video for a second and write the answers on there. And when you unpause it, you'll be able to check and see if you were right or not. So here are the answers to those 3 problems. You can see in the first one that had to be a reflection, because if you look at the x-axis, every point, so the points that pair up, for instance here, if we called that x and called that a, x and a are both the same distance from that x-axis. If we called that b and we called this c, B and C are the same distance. They're both 1 square from that x-axis. On 1B, we know that is a rotation. The center of that rotation is the origin. And so you can see that they are the points that correspond, that go together, are the same distance from the origin. And then in 1C, you can see that one is a translation. Every point shifted the same amount of space. They all shifted 3.5 squares. So that's all we're going to do for tonight. When you come in tomorrow, we're going to look at just a few more things involving this section, and then you're going to be able to get to work in class. See you then.